So research fellow in AI ethics at Stanford University, but for now, still on our own shores here in England. He is based at the Centre of Ethics in Society and the Institute of Human-Centered Artificial Intelligence. Wow. That's the kind of people that we like to bring here. No pressure or anything, but so his work's about the safe and ethical design of emerging technologies. Current research is about ethical design and regulation of ML in medicine and automated vehicles. And you and I have got a podcast episode scheduled, haven't we? And we're going to be going into some of those details in more detail. So broader interests around the ethical decision making under uncertainty, along with foundational questions about the nature of reality, reasons, evidence, and probability. I would keep talking, Geoff, but I'd rather hear it from you than me at this point. So, so grab yourself 20 minutes. We're a little bit over, but we're doing all right. Welcome. Thank you so much for being here. Enjoy.
Cool. Well, thank you very much for that introduction, Richard. And thank you everyone for coming. It's a real pleasure to talk to you here today. What I want to do is talk to you about some questions I've been thinking about at the interface of three different parts of philosophy. So the first is AI ethics, and I assume you all know what that is, the sort of safe and ethical design and regulation of emerging technologies. And then there's medical ethics, which looks at the kinds of challenges that arise in healthcare and how we have best reason to deal with those challenges. And finally, there's philosophy of medicine, which is a part of the philosophy of science, which looks at what clinical reasoning is and how clinical reasoning differs from other sorts of reasoning that you find in other professions. So the basic point I want to make today is that when you build medical AI that aids clinicians in reasoning, you shouldn't do it with these overly theoretical models of what clinical reasoning looks like in mind. Instead, what you should do is think about pragmatic models of clinical reasoning. And what I mean by pragmatic models is models which take into account the role of patient values and preferences in clinical decisions and take into account the kind of communication that you get between doctors and patients as part of the process of clinical deliberation. So I'm going to structure the talk into three parts. The first, I'm going to introduce the kinds of technologies that I'm concerned with. Then I'm going to introduce the ethical problems. And finally, I'm going to look at how, if at all, and to what extent, the philosophy of medicine can help us solve those ethical problems. So these are the technologies I'm concerned with. I'm interested in decision support systems that aid clinical reasoning. So I'm not interested in technologies that make decisions by themselves. I'm interested in technologies that help doctors to make decisions. I mean, the other relevant feature here is that the humans in the loop are expert humans. So I'm interested in people who have relevant medical training and they're just having their decisions enhanced by some AI technology. So let's look at some examples. The first is diagnostic algorithms. So at a very, very, very high level of abstraction, a diagnostic algorithm is a function or an input-output machine. And what you put in is a set of symptoms and maybe other relevant features of the patient's medical history. And what you get out is a differential diagnosis, which is a list of plausible diagnostic hypotheses. So in this case, we have an algorithm called Isabel. The patient has abdominal pain, nausea, vomiting, and tenderness. And the algorithm has outputted a set of plausible explanations for that, including acute appendicitis and pelvic inflammatory disease. The next example we have is a treatment recommender algorithm. I'm very conscious that Hina works for IBM, so I can't say anything bad about this in the present talk. But basically, a treatment recommender algorithm is, again, a function. You put in features of the patient's medical record, and what you get as an output is a list of plausible treatment options for that patient, maybe ordered from best to worst. In the case of IBM's algorithm, it's pretty cool. It uses natural language processing to read and interpret the patient's medical records, and then it outputs treatment recommendations supplemented with sort of medical evidence drawn from this huge database, including over 300 medical journals and 200 textbooks or something like that. What I'm not going to talk about today is other medical technologies that kind of feature in the clinical reasoning process. So I'm not going to talk about image classification algorithms that use deep learning, and I'm not going to talk about health monitoring systems. These kinds of technologies have interesting ethical questions in their own right, but they tend to do with like sort of privacy and discrimination and bias, which are separate questions to what I'm looking at today. So, what ethical concerns arise in the context of clinical reasoning technologies? Well, before I sort of delve into my moralistic criticism, I think we should sort of pause to register the fact that there's good reason to be optimistic with respect to these technologies, right? So there's kind of two reasons for that. One is that diagnostic algorithms are very, very likely to reduce the prevalence of diagnostic error. Diagnostic error is a pretty serious problem. It's the leading cause of medical negligence lawsuits in the US, and estimates vary as to exactly how prevalent it is, but in specialties like emergency medicine, it's thought that up to 15% of diagnoses are either missed or delayed, which results in patient fatalities that would otherwise be preventable. And similarly, treatment recommender systems, the hope is that they will promote personalized and evidence-based treatment plans, and again, reduce morbidity and mortality resulting from suboptimal treatments, which is great. But we shouldn't get too excited because the medical ethicists are presently in a massive panic. And it's like, why are they panicking? Well, the thought is it's unclear how we can reconcile the use of treatment recommender systems and diagnostic algorithms with the current ethical standards that we expect doctors and other healthcare professionals to adhere to. Now, to unpack what that means, it's necessary to say a little bit about what kind of standards medical ethicists think that doctors should be adhering to. And I think the easiest way to do that is to make precise what it is they're trying to avoid. So the view that medical ethicists are trying to avoid is a view called paternalism. And basically, paternalism in a sentence is the view that the doctor knows best. But more precisely, you can think of it as the view that the doctor is morally permitted to act in what they judge to be the best interests of the patient. So if the doctor thinks that X is good for you, the doctor's allowed to bring X about. Now, historically, there's been certain cases in which paternalistic medicine has gone very wrong, where the preferences of patients haven't been duly respected and where patients haven't had sufficient involvement in the healthcare process. So what medical ethicists have done is built in certain safeguards into medical practice to ensure that paternalism can't go too far. And we'll look at two of these. So the first is informed consent. I think everyone knows roughly what that means, so I hope you'll forgive me defining it in terms of itself. But the basic idea is that, other things being equal, physicians are permitted to perform a medical intervention, like a treatment, on a patient only if and because the patient has given informed consent to that intervention. And other things are not equal if, for instance, the patient is incapacitated due to an injury or to some underlying mental health condition, for instance, or if they're a child. Informed consent can be broken down a little bit further into the following conditions. So first, we assume that the patient's decision has to be voluntary. You can't coerce the patient into giving informed consent, and they have to have capacity, which there's a humongous debate about, but basically it means the patient is competent to deliberate about the relevant issue. Then there is disclosure. The doctor needs to tell the patient what's going on. They need to say what intervention they're proposing, what the risks are, what the costs and benefits of the alternatives are, and so on. And the standard that we hold the doctor to is that the patient understands enough about that intervention to make an informed decision. And finally, the patient has to make an autonomous authorization. There's again a huge dispute about what that means, but to shield you from that, the basic idea is that the patient has thought about the decision and authorized it. And if those conditions are met, we say the patient has given informed consent. So how might informed consent conflict with these technologies? Well, consider a treatment recommender system. The treatment recommender system recommends treatments in accordance with certain values. They may not seem like values, but it has to evaluate the treatments in terms of their betterness, right? And the thought is that maybe it will do that in terms of, say, which treatments are most likely to maximize quality adjusted life years or something like that. And what it doesn't do is take into account the patient's beliefs and values when it makes these calculations. To compound that, they also have a limited capacity to explain what values and what features of the patient's medical record actually go into the treatment recommendation. And if you couple the lack of factoring in the patient's values with limited ability to explain how an evaluation was reached, you're in a situation where the patient may struggle to actually know how to factor in the recommendation into their own deliberation, because it will be unclear like what reasons there are for them to factor in to decide whether or not they want to go for the intervention. How much of a worry this is unclear, but what's minimally true is that the medical ethical community is quite worried about this. I suspect the worries will diminish with time as people get more used to these algorithms being used in practice. The other ethical ideal that we'll talk about is shared decision-making. This is basically an extension of informed consent, where the basic idea is that the patient isn't an object of deliberation, but instead an active participant. So the thought is the patient's beliefs and their values need to be factored in at every stage of the clinical process, from assessment through diagnosis and eventually to treatment. To give an example, you might think in diagnostic reasoning that all that matters is the kind of epistemic goal of finding out, what's wrong with the patient. But on the shared decision-making view, that's not true. Instead, you need to think about how much does the patient want a diagnosis, how much would they value a diagnosis, versus how much disutility would they get from, say, enduring a long series of possibly invasive tests that may cause emotional distress, and so on. So the thought is the doctor just needs to be cognizant of what the patient's preferences are with respect to their kind of overall diagnostic care, and then your shared decision-making is satisfied. One thing the medical ethicists are a little bit worried about is how is it that we can factor in diagnostic algorithms into this process, which traditionally involves the patient's beliefs and values, when diagnostic algorithms don't take those things into account? And this remains an open question in medical ethics of AI. So how should we resolve these challenges? Well, a colleague of mine at Cambridge called Runa Nirup and I have been working on this possible solution which draws on certain work in the philosophy of medicine. Let's return to the Isabelle diagnostic algorithm to kind of illustrate what we're thinking about. What you can see is that once the symptoms have been inputted, you get as an output a list of possible diagnoses. And next to those diagnoses are little red flags. And what those red flags mean is that the doctor has good reason to follow up on those particular diagnoses on the grounds that either, it's quite likely to be the case, or it may be unlikely to be the case, but very, very serious, such that there's good reason to rule it out. This presupposes a model of clinical reasoning that's sometimes talked about in the philosophy of medicine that we call the Bayesian view, after like Bayesian probabilistic reasoning. I'm going to illustrate it completely informally with no maths so that we don't make this more complicated than it needs to be. So the thought is, what happens is the patient starts by presenting with a set of symptoms, and I'm going to use peripheral edema, which is basically the accumulation of fluid in the legs. Don't ask me why I picked that example, it just came to mind this afternoon. Then what the doctor does is they formulate a differential diagnosis, which is the set of all the possible things that it could be. And then they assign a set of probabilities to those. Now, these are pre-test probabilities or prior probabilities. And they reflect the doctor's initial kind of hunch about how likely each of the possible diagnoses is. Various factors can be relevant to deciding pre-test probabilities, such as the patient's age, sex, their geographical location. For instance, if it's a 55-year-old man with a history of alcoholism, cirrhosis is fairly likely, and pregnancy is very unlikely. And those kind of factors can be put into the pretest probabilities. Then what happens is you evaluate your probability distribution, and you search for those red flags. So, for instance, heart failure has got a probability of 5%. That's pretty low, but if true, it would be very serious and require an immediate follow-up. So you give that a red flag. And then what you do is you use all your red flags to carry out relevant testing or treatment procedures, and then you update your probabilities based on what you've learned. And you basically keep iterating that process until eventually you're reasonably certain as to what the diagnosis is. So that's the Bayesian view in a nutshell. So you assign your prior probabilities, update the probabilities on the evidence that you get, and then treat in accordance with these probabilistic thresholds. Now, our contention is that the Bayesian view isn't true. It's not reflective of how doctors actually reason. And to support that, because I don't have time to make an argument, I'm just going to appeal to authority. So this is Herbert Simon, one of the great fathers of AI. And he says that doctors probably don't use anything closely resembling Bayesian decision theory in making diagnoses. Instead, what they do is use a process somewhat more akin to 20 questions. And the kind of process that Simon has in mind here is something like this. So when you present with certain symptoms, the clinician will have a kind of flowchart in their mind, and they will ask very specific questions to try and narrow down the diagnosis as quickly as possible and get an appropriate treatment to you. This model we call in philosophy of medicine a strategic reasoning model. So the thought is that clinicians will actively seek out evidence to minimize their uncertainty about diagnoses, and then they will justify clinical acts such as ordering tests or performing examinations in terms of this overall diachronic clinical strategy, the strategy that happens over time. They're looking to get to this end goal of either a diagnosis or just putting the condition in a treated condition so it's not so bad for the patient. And what determines the overall strategy is this kind of dialogue between the patient and the doctor, where the doctor knows what it is that the patient is looking to get out of the medical experience, and then they tailor their clinical reasoning accordingly. And what we claim is that shared decision-making is better suited to this strategic model than it is to the Bayesian model. And there's a few reasons for this. One is that the justification for clinical actions like testing and treating is explicit. There's a kind of there's not an explicit focus on just epistemic value, on finding out what the truth of the matter is with respect to the patient's condition. Instead, you take into account both pragmatic considerations and epistemic considerations. You know, what does the patient want? What are they looking to get out of the healthcare experience? And finally, there's an emphasis on explaining absolutely everything in terms of reference to this overall strategy that's been agreed upon. Now, our take-home message, and I apologize that I've not had time to argue for this in full, is that when designing algorithms for clinical decision support, what we should do is focus more on these pragmatic models of how it is that clinicians reason, rather than thinking about the theoretical models like the Bayesian model. And the reason for that is that the pragmatic models are far better suited to addressing the kind of worries that the medical ethicists are concerned with than the epistemic models are, right? So the worry is that you can see when you think about, say, the Isabel diagnostic algorithm, that they've been reading the clinical reasoning textbooks from the philosophy of medicine, and they've got in mind a very kind of scientific picture of how it is that doctors reason. But the kind of ethical considerations simply aren't registered in those models. What there's good reason to do instead is take these kind of more communicative, more, well, slightly woolly, but kind of more three-dimensional models of what doctors do when they reason, and try and build the algorithms around that picture of clinical reasoning. So yeah, that's the end of the talk. Thank you very much for listening. Here's all the people that funded or hosted the research at some point in its life. Thank you very much.